multiply each term by the LCD. This part here, this is not what we did earlier. So that's what we're doing here when we're solving a rational equation. So just be careful about being clear about, okay, what's our strategy here? Now, in order to find the LCD, I suggest you factor every single denominator, including that 4 as 2 times 2. This denominator, the GCF is 5, and then this denominator's prime is just 5. So the LCD, now remember this, the LCD is the product of each different factor, the greatest number of times it appears in any one factorization. So I can see that I'm going to need 2 copies of 2 in my LCD because 2 appears twice in this factorization. So I'm going to need 2 times 2 in my LCD. That's the same thing as saying 4. I'm going to need only 1 copy of 5 in my LCD because it appears once in this factorization and once for that factorization. So you only need 1 copy. And then you need an x minus 7. So really, this turns out to be 20 times x minus 7. This is the LCD, right? This is what you're multiplying every single term by. So you're going to multiply this term by the LCD. You're going to multiply this term by the LCD. You're going to multiply this term by the LCD. All right, excuse my sloppy work here, but what I did is I put the LCD right next to every single term, and I am multiplying every single term by the LCD. If you do this right, you'll end up with an equation that has no fractions. All right, 2 times 2 is 4. 4 divides into 20 5 times. X minus 7 divides out with x minus 7. 5 divides into 20 4 times. 5 divides into 20 4 times. Now be very careful to write out what you have left over. Here in the front, I have 5x times x minus 7 is equal to, and then I have 4 times x minus 22 minus 4 times x minus 7. Look at this, guys. This equation seems less intimidating to solve. So now what we'll do is we'll distribute 5x. Here we'll distribute the 4. Be careful here. You'll be distributing negative 4. Be careful with your signs. Let me move us up here. All right, so after distributing, we end up with 5x squared minus 35x is equal to 4x minus 88. Be careful, you're distributing negative 4 here. So negative 4x and then a positive 28. Again, please, please, please be careful with your signs. On the right, notice that 4x cancels with negative 4x. And then you can combine these two terms here because they're constants. So that gives you 5x squared minus 35x is equal to negative 60. What kind of equation do we have as a result here? Because we no longer have a rational equation because you got rid of the fractions. We have a quadratic equation. Now, if you recall, whenever we have a quadratic equation, we most of the time set them equal to 0 and then solve. So in order to set this equal to 0, what I'll do is I'll add 60 to both sides, right? Because you want negative 60 to go from the right side to the left. That way you get 0 right here, right? So then you get 5x squared minus 35x plus 60 is equal to 0. Now here is where your factoring skills come into play here even more. You want to solve by factoring. So remember that the first step in factoring a trinomial is to see if you can factor out the GCF. And in this case, the GCF is 5. So when you factor out a 5 from every single term, you're left with this resulting trinomial inside. Now remember, this is an equation set equal to 0, okay? Don't lose that. That's very important. And then I hope you feel confident in factoring this trinomial as x minus 4 times x minus 3. The zero factor property at this point says take every single factor, and you have 3 factors here. You have a monomial factor, and then you have a pair of binomial factors. Take each one separately and set them equal to 0. Now, this is a zero factor property that you and I just used, because after all, this factor times this factor gives you 0. That must mean by logic that one of these factors must be equal to 0. Now, this first statement here is silly. It's extraneous. It doesn't make sense. 5 is not 0, so I kind of disregard that one. For these, in order to solve for x, for this one, I'm going to have to add 4 to both sides. For this one over here, I'm going to have to add 3 to both sides. So then I get my final solution of, I get x is equal to 4 or x is equal to 3. These are my final solutions. That was pretty lengthy in as far as the process is concerned. Remember what we did first is we factored the denominators, found the LCD, multiplied each term by the LCD to eliminate the fractions. We ended up with something quadratic. We set it equal to 0. We factored in order to solve. I thought you might appreciate, before we end this lesson, a little summary, differentiating between the processes of adding or subtracting rational expressions from the process for solving a rational equation. So check this out. I hope this is helpful. Here are the steps for adding or subtracting rational expressions. First, factor all polynomials, but the ones that are most important are factoring the denominators, but I just put factor all polynomials. Most of the problems have you factoring the denominators. A lot of times the numerators are prime or the numerators are already factored or whatever, so it's really factoring the denominators, but I just put it in factor all polynomials just to be safe. So the first thing you want to do, factor, factor, factor. After you have everything factored, look at your denominators and build or find the LCD. Remember, it's the product of each different factor the greatest number of times it appears in any one factorization. Now that you know what the LCD is, get common denominators. Once you have common denominators, then you can add or subtract, okay? Now let's look at the process for solving a rational equation. All right, to solve a rational equation, you factor all polynomials. Notice that first step is the same. Factor, 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 especially the denominators, okay? Find the LCD. That's the same second step as well. Find the LCD. Now here is where the process changes. Once you have the LCD, you are not getting common denominators. You are multiplying each term by the LCD. If you do this step right, you'll have an equation that has no more fractions. Solve that equation. Solve the resulting equation. A word about this step here. Sometimes when you eliminate the fractions, you end up having an equation that's quadratic. If you have an equation that's quadratic, like the previous example, set it equal to 0 and solve, usually by factoring. If you have an equation that's linear, then isolate the variable. Get the variable on one side, get your constants on the other. It might be helpful to have this in your notes. After you multiply each term by the LCD, sometimes you're left with a quadratic. Try this approach. Set it equal to 0. Try factoring. I say try because not every quadratic will factor. If it doesn't factor, then you might want to use maybe the quadratic formula or something like that. which we haven't discussed yet in our class. But for this point in this class, try factoring, okay? Set each factor equal to 0, and then you can solve. If it's linear, if it's a linear equation, then just isolate the variable, which means get the variable on one side, your constants on the other. All right, everybody, I hope this lesson was helpful for you. I'll catch you in the next lesson, all right? See you later.